The topic of this video is the median of a triangle and centroid, but before we can define those two things, we need to understand what the vertex is and also what the side opposite the vertex is. So in this small triangle here, we'll take the vertex C. C is opposite the side AB. If I were to take A would be opposite side BC. And so if you are thinking ahead, B would be across from side AC. And so that's what the vertex is, and also what the side opposite the vertex is.
Hey, if you haven't liked, shared, or subscribed yet, go do that now. Okay, bye.
The definition of the median of a triangle is that it connects the vertex to the midpoint of the side opposite the vertex. So again, if I take C, I will be connecting this vertex to the midpoint of the opposite side. Now keep in mind that the midpoint means that you have two congruent parts, so this is why we have two tick marks here and two tick marks here, to show that AD is congruent or has the same measure as BD. So if AD measures 6, then obviously DB will measure 6 as well. And also if you're given the full length of AB, let's say it is 10, then we can say that AD is 5, and then DB is the other 5, that makes 10. So just keep that in mind. That is the relationship. Once you have formed a median, that means that you're connecting the vertex to the midpoint of the opposite side. Now, if you think about the question, how many medians are in a triangle? Well, you have 3 vertices and you have 3 sides. So that means you have 3 medians. I'm going to highlight that in red. So DC is 1 median, BF is another median, and finally AE is your 3rd median. Now, you might have guessed by now that this point is going to be special, and that is in fact the centroid. It is where all your medians meet. Now, why is this important? Before we get into that, let's talk about something. If you think of thirds, it means there are 3 parts. So if I have 2 thirds, to make a whole, I would need an additional third so that I can have a whole. The reason this is important is because the distance from your vertex to the centroid is 2/3 the measure of the entire median. So again, from the vertex to the centroid, and it could be any one, so from B to G, from A to G, or from C to G, represents 2/3 the distance of the full length of the median. So let's take our first example. Let's say that the length of BF is 48. So that means the full length of this median measures 48. If I want to find the measure of BG, that is actually the distance from the vertex to the centroid, which means it's 2/3 of the way. So to find the length, I just need to multiply 48 by 2/3. Which is 32. So again, from B to G is 2/3 of the distance. Again, because from B to G is from the vertex of the centroid, which is 2/3 of the full distance of the median. which means that GF is just 1/3 of the measure. So GF is 1/3 of 48, and 1/3 of 48 is 16. Now keep in mind that these two measures must add up to your total, so that would be correct. So again, the full distance is 48. From the vertex B to the centroid G measures 32, and then from G to F measures 16 for a total of 48. Now it's easy enough when you have the full length, but what if you don't and you're just given a part of it? Let's say that AG measures 30. So from the vertex to the centroid measures 30. Now that does not give us the full measure of the centroid, it just gives us the 2/3 portion. Now since we can identify that this is the 2/3 portion, to find the full length you simply just have to multiply by the flip of the fraction or the reciprocal. So to find AE, I would just multiply 30 by 3/2. And again, it is because AG represents the 2/3 part, and so to find the full length, just multiply by the reciprocal, which is 3/2, which is 90/2, which is 45. So that means the full length is 45, from A to E measures 45. Now you have a couple of options. You know that part of it is 30, so to make 45, then this part must be 15. Or you can take a fraction, since you know that GE represents 1/3. GE would be 1/3 of the whole. Now keep in mind we found out that the whole was 45, so 1/3 of 45 is 15. So make sure to go back and double check your answers. Remember that AG, which is the 2/3 part, plus GE, which is the 1/3 part, should be equal to AE, which is the full length. We were given that AG was 30 here. We found that GE was 15, and then we also found the total was 45, which makes sense. Now, what happens if you're given the 1/3 part? How would you solve a problem like that? Let's do an example like that. So let's use DC. Let's use this median this time. Again, from the vertex to the centroid represents the 2/3 portion, and then from the centroid to the midpoint would be the 1/3 portion. Let's say that DG is 7. So DG measures 7. That means we have the 1/3 portion. So to find the full part, we just need to multiply by the reciprocal of 1/3, which is 3/1, just turning your fraction upside down. So to find the full length DC would be 3/1 times 7, which is just 21. So the full measure is 21. But again, what if you are asked for GC? Well, if you have the full length, you can always just multiply by 2/3. So GC would be 2/3 of the full measure being 21. And that works out to be 14. So let's double check. We need to make sure that DG plus GC gives us the full measure DC. DG, we were given, that was 7. GC is 14 here. And then DC measures 21. And that works out well. And so that's what you would do if you were given the full length, you were given the 1/3 portion, or you were given the 2/3 portion. If you have the full portion, either multiply by 1/3 or 2/3, depending on what part it represents. And if you're given either the 1/3 or the 2/3 portion, multiply by the reciprocal of those fractions to find the full length depending on which portion you're given. So hopefully this helps.